This looks like a standard algebra problem, but it's actually a classic Harvard entrance exam question. So we have b cubed minus b divided by b is equals to 2, and we solve this problem for all the values of b. So by the end of this minute you will know exactly how to manipulate these bases to solve for values of b like an Levy Lake student. Okay, so here we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So we move toward the solution of this problem from first method, and here we move the value b from left hand side to the right hand side, and it will becomes b cubed minus b is equals to, when we multiply it by here, it will becomes 2b. So further in the next step we need more simplifications, and it will be written as b cubed minus b is and here we again move 2b from right hand side to the left hand side, and it will becomes minus 2b, and this whole equation is equals to 0. And further in the next step we need to add or subtract the like terms. So we have these two like terms, minus b minus 2b becomes minus 3b, and this whole equation is equals to 0. You see that both of these two terms involve b, so that we will be take common b from here, and after taking common b we get the remaining values are, from here we get b square minus from here we get 3, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write b is equals to 0, and the second case is we write b square minus 3, and this whole equation is equals to 0. So this is the first root of the given equation. And now here, in order to find the other roots, we need to solve this quadratic equation. For this we move minus 3 to the right hand side, and we get b square is equals to 3. So here further we find the values of b, so that's why we remove 2 from here. So for this we apply square root on both of the sides. So when we apply square root, it will be written as this 2 and square root are gone, and we get here b is equals to, here this is the square root of 3, and we write it as plus minus square root of 3. So these are the other two complex roots of the given equation. So we have b is equals to 0 and b is equals to plus minus 3b, the two roots of the given equation. And now in the next steps we need to verify that is these roots be the solution, or is these roots be the extraneous root. For verification of this we need to copy down given question statement. Here it is b cubed minus b divided by b is equals to 2. In this side we will take b is equals to 0, and in this side we will take b is equals to plus minus square root of 3. So here first we verify, here we verify both of these two values separately, but here we verify a first positive value only, so that now first we substitute b is equals to 0 into the left hand side, and we check its behavior. When you put it here, it will becomes 0 cubed minus 0 divided by 0 is equals to 2. So you see that 0 cubed becomes 0, and 0 minus 0 becomes 0 over 0 form equals to 2, and 0 over 0 form is usually called that it is indeterminate form, or in other words we say that it is undefined form. So if our left hand side is undefined form, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that b equals to 0 is not satisfied our given question statement, and we call that b equals to 0 be the extraneous root of the given equation. Okay, this is the extraneous root because it does not satisfy our given question statement. And likewise we need to verify the second root or second value of b, so that we substitute b equals to plus square root of 3 into the left hand side, and we see that this will becomes square root of 3 and its whole cubed minus square root of 3 divided by square root of 3 is equals to 2. So here you see that in the numerator side we have square root of 3 be the common value. So when you take common square root of 3, we get the remaining values are square root of 3 and its whole square minus 1 divided by square root of 3 is equal. Further, in the next step we need more simplifications, and we have this square root of 3 and this square root of 3 are gone, and we obtain here these 2 and square root are gone, and we get here 3 minus 1 is equals to 2, and you clearly see that we obtain 2 equals to 2. This shows that both of the sides are equal. It means that the value b is equals to positive square root of 3 is satisfied our given question statement. So in the same pattern, we verify the third value of b, and the third value of b is equals to minus square root of 3. So we put b equals to minus square root of 3 on both of the sides of the given question. And after substituting this, it will be written as minus square root of 3 and its whole cubed minus times of minus square root of 3 divided by minus square root of 3 is equals to 2. So here we have you know about that when we apply square root, when we apply cube on negative term, it will becomes negative, and this will be written as minus times of square root of 3 and its whole cube. This is minus times minus becomes plus square root of 3 divided by minus square root of 3 is equals to 2. And further, in the next step, you see that in the numerator side we have square root of 3 be the common term. So when you take common square root of 3, we get the remaining values are minus square root of 3 whole square plus 1 divided by square root of 3, and this is equals to 2. So this square root of 3 and this square root of 3 are gone, and we obtain this is this 2 and square root are gone, and we get here minus 3 plus 1 divided by minus 1 is equals to 2, and minus 3 plus 1 becomes minus 2 divided by minus 1 is equals to 2. So we have 2 equals to 2. So this shows that the second value of b is also satisfied our given question statement. So finally we have the solution set of this problem is b is equals to plus minus square root of 3. So this is our final answer from first method, and now we again solve this problem for second method. And so for second method, we need to copy down given question statement. Here it is b cubed minus b divided by b is equals to 2. So this is our second method, and here we need to break this fraction, and when we break this fraction it will be written as b cubed divided by b minus b divided by b is equals to 2. This b and this are gone, and we get here b square minus this b and b are gone, and we get here 1 is equals to 2. So we move minus 1 to the right hand side, and we get here b square is equals to 3, and for the values of b we apply square root on both of the sides. So this 2 and square root are gone, and we get b is equals to plus minus square root of 3. So in the second method we quickly get these are the two roots of the given equation, but in the first method we already verified that both of these two values satisfied our given question statement. And finally we have the solution set of this problem is plus minus square root of 3. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.